discussed earlier involve carbon. Carbon has a molar mass of 12.011 grams per mole. In other words, 1 mole of carbon has a mass of 12.011 grams. Potassium, as you recall, has an elemental symbol of K. It has a molar mass of 39.10 gram per mole. So the unit of molar mass is grams per mole. And what we're going to use in our problem-solving strategies, we're going to use molar mass as a conversion factor to solve problems using dimensional analysis, similar to the problems we solved in Chapter 1. So let's go through our first example for today. And I will have these posted on our PowerPoint that you should review for your quiz and for our first exam, which I'll be announcing a little bit later. Let's go through our first problem. Let's write down what example 1 is discussing. So this is example 1 on today's PowerPoint. Problem asks us, what is the mass in grams of 12.4 moles of lead? And lead has an elemental symbol of Pb. So when we are starting any problem, I went through a strategy of writing down what you have, what's given, and what you desire. So what's given in this problem, 12.4 moles of lead. What we desire as an answer is the mass of lead, and we want our answer in grams. That's our big question here. Well, we also have other pieces of information that you need to refer to in some cases. And the most important piece of information is found in the periodic table. So we're going to learn more about the periodic table in Chapter 3, but for now, let's just use a number from the periodic table that's going to help us solve this problem. If we look at the periodic table for lead, we see a number on it that's listed here as 207.2. And remember, we said that this number, this decimal number, is the average atomic mass. And what that tells us is that 1 atom of lead is 207.2 atomic mass units. But it also tells us that 1 mole of lead has a mass of 207.2 grams. This is our conversion factor, this value from the periodic table. And remember how we use conversion factors. We use conversion factors as a ratio. And what we use in this case is the ratio that has moles in the denominator and grams in the numerator. Let's set this up as a conversion factor and multiply this value by our desired conversion factor. Our conversion factor that we're using is the fact that 1 mole of lead has a mass of 207.2 grams. If we multiply this out, and we would get an answer of 2,560 2,569.28 grams. Okay, let's first of all look at our conversion factor to make sure we used it properly. Our units that we are given are in the numerator, and they cancel the units that were given because now they're in the denominator, and we get an answer that's in grams. So far, we're doing a good problem here. Let's look at our answer now. The answer that we get, 2,569.28 grams. How many significant figures should we report this to? Well, the data that was given to us was this 12.4 moles. Our answer should be limited to 3 significant figures. So let's round this, 2,500. Now we're going to drop these digits off, and that means we're going to round this up. And that's one way to report it. This would be an appropriate answer. We could also write this in scientific notation. Notice I dropped the 0 because it's not significant. That's also a correct way to write our answer. You could also write this 2.57 kilograms because there are 10 to the third grams in 1 kilogram. Either of these 3 ways are correct when you give an answer using 3 significant figures in this case. So does our answer make sense? Well, if 1 mole of lead is 207.2, 10 moles would be about 2,720. So we're over 10, we're at 12. Our 2,570 grams seem kind of reasonable. So this is one way to solve a problem. Let's try another example. Let's try one more example. Example 2. Example 2 says, how many moles are in 0.568 grams of iron? And iron has an elemental symbol of Fe. You can stop the video and try the problem on your own, but I'm going to go through the problem-solving strategy. So if you want to stop it and try it, go ahead and stop now. Let's begin our strategy such as we did before. Let's write down what is given. In this case, we're given 0.568 grams of iron. And what we desire are the moles. What are we going to use as a conversion factor? How do we convert units? How do we go from grams to moles? In this case, we need to turn to the periodic table once again. Let's look up the periodic table, and what we would see for iron, for Fe, 1 mole of iron has a mass of 55.85 grams. Notice iron and lead, they have different masses for 1 mole, and that's simply because different atoms have different numbers of protons, different numbers of neutrons, and it gives us different masses for each of these in terms of the mole concept. Let's use this as our conversion factor. Now, this conversion factor is going to use grams in the denominator And in this case, it's 55.85. For each mole of iron. Grams cancel out. We get an answer in mole 0.0102. And I limited myself once again to 3 significant figures. And that's because the original piece of data that we're using also has 3 significant figures. Does our number seem reasonable? Well, let's see. 1 mole has a mass of 55.85 grams, or roughly 56, about 56 grams. Good? What would 0.1 mole weigh? 0.1 mole would be about 5.6 grams. How about 0.01 mole? 0.01 mole would be about 0.56. And that's what we have. We have roughly 0.56 or so, and we have roughly 0.01 or so. Once again, our answer seems reasonable. Good idea to check on the reasonability of your answer. This way, if you had an error with your calculator, you'll know. Just always check if your number makes sense. So let's just review our problem-solving strategies. Let's review. So, if we're given moles, and we desire mass, and mass is typically grams, what we're going to do is multiply by that substance's molar mass. If we're given mass and we desire moles, we need mass in grams. We divide by molar mass. So these are just some general rules, some general strategies to help solve problems. We'll do a few more in part 2 of our lecture, and then part 3 will begin chapter 2. Thank you.